So if I had to classify one subject that we've talked about so far this year that is really truly algebra, like when people think algebra, this is what they think of. It would be polynomials. So polynomials is a section that we're getting ready to start. And a polynomial is an expression with many terms. And when we look at polynomials, sometimes they look ugly. When I'm looking down here, some of these look ugly and they're kind of scary. But all it means for something to be a polynomial is for it to have several different things going on all at once. It can be one letter, it can be two letters, every single thing in a polynomial could all have different letters, and that's okay. When we talk about polynomials, a lot of times we talk about writing our answer in standard form, and we're going to start that skill from day one, writing things in standard form. And writing things in standard form just means that all the letters are in alphabetical order and my big exponents go first. And this first set of problems has us taking these polynomials and putting them in standard form. When I'm putting things in standard form, not only am I ordering, so if I look right here, and I like to highlight because the color works best for my brain. I'm looking, I have an x with no exponent, I have a 1, I have 2x squared. Well, the biggest exponent is that 2x squared. I don't care about the coefficient that the 3 is bigger than 2. I'm simply looking at the exponent. So in standard form, 2x squared would come first. If I look, my next biggest exponent or variable would be the 3x by itself. So plus 3x. And then we're going to end it out with this plus 1. Same thing on my next set. My biggest exponent is k to the third. So my problem is going to start out 7k to the third. The 3, there we go. My next biggest exponent is k squared. So plus k squared. And then I have this minus k by itself. And then my number that doesn't have an exponent at all, plus 64. Go ahead and pause the video. Do number 3, number 4 by yourself, and then I want you to continue the video, and the video will walk through number 5 and number 6. So let's go ahead and give answers, just so my absent people have something to check themselves with. Negative n cubed plus n plus 24. So when I look at number 5 looks kind of ugly compared to the other problems that we just did. Because number 5 introduces a second letter. We now have an A and we have a B. So when I'm doing something like this, I'm going to make a little note out to the side. All of my A's go before the single B. So what that means, I'm looking to AB. I have an A with no exponent. I have A cubed right here. I have an A squared. And then I have something without an A at all. So my biggest A that I can see on here is this A cubed. A to the third power. So my problem is going to start out A cubed My next one, I have a without an exponent, or a squared, so a squared is bigger. That whole thing is going to get written down. 5a squared b squared. The entire thing, the a2, is what's important there. Then I have 2ab, so a without an exponent, or b cubed. I'm still doing my a's first, so my plus 2ab would come next. And then to finish us out is going to be this lone b all by itself. Negative b cubed. That's a 3, I promise. Negative b cubed. Same thing for number 6. We're going to do the c's first because c comes before d in the alphabet. I have c cubed, c squared. So c cubed is going to be my biggest c, specifically negative c cubed. My brain is not working today. Let's try that again. Negative c cubed. And then I'm looking for the next biggest c, which is going to be c squared, c to the second. So negative 7c squared d squared. That wraps up all of my c's. So now I'm going to go to the next letter in the alphabet. Plus 5d cubed. And then we're going to finish out with this lonely 13. So that's what we're doing when we're writing things in standard form. We're putting them in alphabetical order. We want to make sure that our big exponents come first. And we need to know how to put things in standard form because our next set of questions, just kidding, we have something else before our next set of questions. When we talk about polynomials, we classify them, and we talk about classifying them by their degree and their number of terms. So their degree is just a fancy way to say their exponent number. So a degree of 2 is like, an example would be x squared. A degree of 3 would be x cubed, x to the 4th. A degree of 1, I could say x to the 1, but what we're really going to see on a test, they're not going to have the 1 there. They're just going to have an x. So a degree of 0, there'd be no variable. There'd be no letters there at all. A degree of 0 is called a constant. When I'm looking at number 7, it's just a 6 by itself. There's no letters. That is a constant. A degree of 1 is called linear. So, and it just has a letter by itself. There's no exponent. So look at number 8, negative 2x. It would be linear. Notice, linear doesn't have does not have an exponent. The coefficient's fine. I don't care about it. All I care about is that the x does not have a tiny exponent. A degree of 2 is a quadratic. When I look at 10, I have b squared. This v squared right here makes this a quadratic. Anything cubed to the 3rd power is cubic. 4a cubed, I have that tiny 3. So this is cubic. And number 4 is quartic. 2m to the 4th power is a quartic polynomial. When I'm looking at number of terms, it's asking me how many things there are. So one term is called a monomial. This 6, it's one thing. It's a monomial. Negative 2x is one set. It's just one thing. So it's a monomial. Mono, meaning one. 2 is going to be binomial. So when I look at number 9, 7p plus 1, we have two separate things. 2 would be, or number 9 would be a binomial. Bi meaning 2. For 3, we have tri. Tri meaning 3, a trinomial. B squared plus 2v minus 5. We have 3 separate things going on. Anything more than 3 is a polynomial. We've got 4 or more things. We have a polynomial. I want you to finish on number 9. Tell me the degree based on your exponent. Then on number 11, classify it by the number of terms, and then continue on. So classifying and putting things in standard form is just leading us up to this idea of adding and subtracting. This is something that we have done before, even if they didn't look this ugly. Adding and subtracting is simply combining like terms. And this is where I love my highlighter. So when we combine like terms, again, we're going to start with the highest exponent. So when I'm looking at everything on here, the biggest exponent that I see is x squared. So I have a negative x squared and a positive, because I'm adding, 2x squared. Negative x squared plus 2x squared would just leave me with x squared. Then I'm looking for my next highest exponent, which in this case is just an x by itself. So 11x and negative 5x. Well, 11x minus 5x is a positive 6x. And then we're going to combine our constants. A positive 13 and a negative 23. 13 minus 23 is going to be negative 10. We're always going to make sure that our answer is in standard form. My biggest exponent, x squared, followed by an x without an exponent, followed by my constants. Let's do one more addition problem, and then I'm going to train you loose before we talk about subtraction problems. So I'm going to jump down to number 15. When I'm looking at my exponents, the biggest exponent that I see is w cubed. So w cubed is going to come first, followed by my squareds, negative 2w squared and 3w squared. Negative 2w squared plus 3w squared is just going to leave me with 1w squared. And then my constants, negative 5 and negative 11, which leave me with negative 16. I want you to do the other addition problems. So number 13, number 14, number 16, number 18, and number 17. Pause the video, do those 5 problems, and then when you play the video again, I'll have the answers there for you. Okay, so you can pause the video for a second. You can check yourself on these 5 addition problems. Then we're going to continue on to our subtraction problems. The only difference about subtraction is I like to put in an extra step because it helps a little bit. If I take the subtraction and I think of it as negative 1, subtracting things just change the sign. So subtracting 7x is really like saying negative 7x. Subtracting 3x squared is really like saying negative 3x squared. Subtracting negative 1 is really, subtracting a positive 1 is really like saying negative 1. I didn't do anything to change that problem up top. But if I take a second and I distribute that minus sign, that negative, it makes combining my like terms a lot simpler. So we're going to start out with my highest exponent, which are my x squared. 4x squared minus 3x squared, which is just going to leave 1x squared. Then my next set, positive 5x minus 7x's, which is going to leave me with negative 2x's. And then I have this negative 1 all out by itself, minus 1. We're going to do one more on this video, and then I think we'll be good to go. So I'm going to distribute my negative, or my minus, so negative 3x squared minus 5x. My beginning didn't change. So I can combine my like terms, my biggest exponents. X squared minus 3x squared is going to leave me with negative 2x squared. 17x's minus 5x's are going to leave me with a positive 12x's. And that's where we're going to go ahead and wrap up the video. There are a few more problems on this note page, and then you should have a homework attached to it. Our homework is 20 questions, and it's going to be due on Thursday of this week. Let's get busy.